Now this is B. Now this entire flux is, now remember this entire portion, one circle here is of area pi r square. Flux is B into pi r square per turn. So the total flux is n times pi mu naught by 2 pi. Just a correction. Why? Because small r is internal radius. This one, capital R is internal radius. Small r is the radius of cross section of the tube. Mu naught by 2 pi n square by r I times pi r square. That is the total flux. By pi cancel. So the total flux is mu naught n square r square by 2 times capital R times I. So the self-inductance is mu naught n square r square by 2 times capital R. That is the expression for. Are you shocked? Phi proportional to I, phi is L times I. In the place of L, we have this. Remember n square, not n. Any doubts? Ishant, have you followed this? Palvita.
Yes, sir.
Palvita, have you understood?
Yes, sir.
No, you are absent yesterday. Why? Gaurav, you didn't came yesterday's class. Right. Nidhi, వచ్చావా?
Yes, sir.
నిన్న క్లాస్కి వచ్చావా?
నిన్న రాలేదు, sir.
ఏమైంది?
It was not fun.
Don't tell me like that. Yeah. You are watching all these things at your home in spite. Next. This is a very important model. And then there is a name for this model. Magnetic. This is on the basis of conservation this is on the basis of conservation of magnetic flux. This is on the basis of conservation of magnetic flux. Right. Now, in the circuit shown in the figures, which is shifted to position 2.
సార్ మీరు రాసేది కనిపిస్తలేదు సార్.
అదేంట్రా?
అది స్క్రీన్ మూవ్ అయితే లేదు సార్, అక్కడే ఉంది.
అరే ఒక్క నిమిషం. ఎందుకు అట్లా అవుతుంది వాళ్ళ? Right. Is it clear now?
ఎస్ సార్.
Right. Now see, while switch is in S1 state, while switch is in S1 state. Okay. So you have a steady current passing through Of course, you have some resistance over here. A steady current is passing through here. You know what is that steady current? Let this be I naught, E by R. And this is the steady current that is passing through this inductor. And this causes some flux. Right. And that flux is Li, and that should remain constant. Suddenly, when you throw the switch on to this, in this event also flux should conserve. So therefore, whatever the flux here, that should be, for example, initially this is L1, I1, finally that should be L1 plus L2, I2. 5L times initial current is E by R, L1 plus L2, 9L times I2, LL cancel. So immediately after throwing switch, you will find this. From 1 to 2. That's the deal. So you have 5 by 9 E by R for this. Any doubts? Conservation of magnetic flux standard model. Boys and girls, if you have any doubt, please ask me right now. Or at least someone please tell me, have you followed or not? How do I know that whether you understood this or not? Palvita, Aditya, నువ్వు చెప్పరా నిన్ను స్టాండర్డ్ గా పెట్టాను కదా నేను.
Yes, sir. Understood, sir.
పక్కానా?
Yes, sir.
Right. Let us move on to the next model. Today, excellent problems I am discussing about. I'm discussing about really, really excellent problems. It's all yours. Start working on this. If S is closed at t is equal to 0, the change in flux in inductor from t is equal to 0 to an instant when it reaches a steady. Asal first draw steady state circuit. What is a steady state circuit? Steady state circuit. What is steady state circuit? This is the steady state circuit. In the place of inductor, I'll straight away take a conductor. I am asking about these 2 points, AB, and you have these 2 points, AB in steady state. And apart from this, remember this is 20 volts. Apart from this, you have another 10 volts here. You have 10 volts here. Or sorry, call attend also. Right now you have another resistor here. And this is 5 ohm. And rest everything is a resistor and a capacitor. That is fine, no issues. What do you want? Are in steady state? This is the circuit. Remember, this is 5 ohms. And the drop across these 2 points will be 20 by 5, 4 amps. Now, therefore, flux is equal to L times I. Flux is 500 milli into current 4. Actually, you are supposed to report the answer as 2 Webers. Why? Because 20 by 5, 4, because there is no resistance for the inductance. The change in the flux in the inductor, this is the flux finally in steady state. This is the flux finally in steady state. Fine, everything is good, looking good. But they have given the answer as 1.5. I'm asking a question. Have I done any mistake in this? Straight question to you all. Whatever that I have written is the final state situation. What is that you are asking me now is a change in flux. Is this the change in flux or anything else?
No, sir, this is not change in flux.
Why?
We should consider initial current also and multiply and subtract
Super,
the
super, Nana. Chala baga chesaru nubbu. In this 59th question, if you can see current through the inductor before closing the switch also you need to consider. This is before closing the switch, the flux initially is L into I. L into I. Bhaiya class lo unna 12 taravu cheyna. Bhaiya ఒక్క క్లాస్ లో ఉన్నా రికార్డ్. రైట్ రవితో మాట్లాడుకుని ఏది చేస్తారో అది చేసేసుకోండి. రైట్ గో అహెడ్ రైట్. నన్ను ఏం చేయమంటారా, మేనేజ్మెంట్ లో ఉన్నాను నేను, మరి నా కాల్ చూస్తూ ఉంటే ఫ్లక్స్ ఐ ఈజ్ ఈక్వల్ టు ఎల్ ఇంటూ ఇనీషియల్ కరెంట్. ఒరే ఇందాక ఆదిత్య అన్నారు చెప్పింది, ఆదిత్య నువ్వేనా చెప్పింది?
Yes, sir.
ఒరే
Yes,
నువ్వు సూపర్ చదువుతున్నావురా, నేను చెప్తున్నా నువ్వు ఇలా చదివితే 100లో కూడా వచ్చేస్తాను, టాప్ 100లో వచ్చేస్తావు. రైట్. నెక్స్ట్ ఒరే నేను ఎగ్జాంపుల్గా చూపిస్తాను రా అప్పుడు. ఇప్పుడు ఇక్కడ స్టడీ స్టేట్ కరెంట్ ఎంత అవుతుందో నాకు చెప్పండి. ఇనీషియల్గా బిఫోర్ క్లోజింగ్ స్టడీ స్టేట్ వచ్చేసేటప్పటికి ఎల్ మామూలే దిక్కుమాలిన 500 ఇంటూ 10⁻³ కరెంట్ ఎంత? అరే అప్పుడు ఇది లేనప్పుడు స్టడీ స్టేట్ కరెంట్ ఎంత రా? దీనిలో 5 ohm, 10 volts,
1 ampere.
1 ampere. సో కాబట్టి 1 అంటే ఇది వచ్చేసి 0.5 వెబర్. ఒరే ఇనీషియల్ ఫ్లక్స్ 0.5 వెబర్, ఫైనల్ ఫ్లక్స్ 2 వెబర్. వాడు అడిగినది అది కాదు కదా, చేంజ్ ఇన్ ఫ్లక్స్. 2 minus 0.5, 1.5 వెబర్. Any doubts, boys and girls? Any doubts? Are we clear?
No, sir.
Are we clear?
Yes, sir.
అరే ఒక్క నిమిషం, మీరు ఎన్నోటేషన్స్ చేస్తే ఇవన్నీ మీకే వస్తాయి రేపు. రైట్. నెక్స్ట్ ఒరే ఇప్పుడు నేను చెప్పే క్వశ్చన్ అయితే బ్యూటిఫుల్ క్వశ్చన్. ఆ క్వశ్చన్ చూడండి ఎంత ఉందో. ఒక్క కాన్సెప్ట్ మీద 6 క్వశ్చన్స్ అడిగారు. ఇది చేస్తే మొత్తం వచ్చేసినట్టే. నేను మళ్ళీ చెప్తున్నా, ఎక్సలెంట్ క్వశ్చన్. ఎక్సలెంట్ అంటే ఎక్సలెంట్. Let me see how many students will do this. If you do first option, that's all. You know how to solve this. ఆదిత్య ట్రై చేయి. పల్విత, ఈ అమ్మాయి వచ్చిందా ఇవాళ? సంజన, క్లాసులన్నీ విన్నావా లాస్ట్ వీక్వి ఈ వీక్వి?
Yes, sir.
రైట్. బాగా జాగ్రత్తగా చూడండి. ఎట్ ద జంక్షన్ I1, I2, IL, for example, you take it as IC for a while. Now, according to Kirchhoff voltage law, you can write as I1 plus I2 is equal to IC plus IL. Sir, how do you know the direction of VC? Yes, good question. They have given VC. And VC is decreasing. If it is decreasing, the direction of the current, I mean battery is discharging actually. Sorry, capacitor is discharging. అరే మీరు మిమ్మల్ని మీరు మోసం చేసుకునేది ఎక్కడో తెలుసా? బ్లైండ్గా వినేస్తే మోసపోతారు మీరు. మీరు ఆనెస్ట్గా చెప్పాలి. హ్యావ్ యూ అండర్స్టూడ్ ద డైరెక్షన్ ఆఫ్ ఐసి? ఎనీవన్ ఇన్ ద క్లాస్? నిధి, హ్యావ్ యూ అండర్స్టూడ్ ద డైరెక్షన్ ఆఫ్ ఐసి క్లియర్లీ?
Yes, sir.
Sure? Right. Next. Geetika, have you understood the direction of IC?
Yes, sir.
How?
They have given discharge means so positive charge and
Right.
negative
So
charge.
therefore, positive towards negative, it should be the direction. And one more important point is, at any instant, Q is equal to CV, and minus dq by dt is IC actually here. This is minus C differentiation of V, 3 into minus 2 into e to the power of minus 2t. 6, 12. 12 times e to the power of minus 2t. That is the current IC, equation 1. See, that is the first realizing step. If you fail, you cannot solve anything. Right. Any doubts, boys and girls? Now you
No, sir.
use equation. This is called Kirchhoff current law. Now KCL implies, boys and girls, 10 times e to the power of minus 2t plus 4 amperes is equal to 12 times e power minus 2t plus IL. So clearly IL is 4 minus 2 times e power minus 2t, which you can write it as 2 minus e power minus 2t. Yes. Any doubts? Please ask me. What is the current IL? 10, 4 minus 2 into, that's what I got. Are option 2 is the same? Yes or no? Option 2 is the
Yes.
same. 2 plus 2, 4. 4 minus 2 times e power minus 2t. It's the same. Aditya, am I right or not?
Yes, sir.
So match. I got the so there. Everything is the variation of current in the inductor with time can be represented as what is there in this? Come on, man. I don't even require all the graphs are there. No issue is that yet t is equal to 0. See, maximum value is 4. Minimum value is 2. So the graph should run between 2 to 4. It follows like this exponential graph. మామూలుగా మీకు గ్రాఫ్ ఇలానే ఉంటుంది యాక్చువల్గా మీరు హైడ్ చేస్తే మా సపోజ్ ఇది ఎక్స్ యాక్సిస్ అనుకోండి 1 మైనస్ ఈ పవర్ మైనస్ టీ ఇలానే ఉంటుంది బట్ ఏంటంటే ఇట్ ఈస్ డిఫరెంట్ గ్రాఫ్ 4 మైనస్ 2 పవర్ ఈ పవర్ మైనస్ 2 పుట్ టీ ఈజ్ ఈక్వల్ టు 0 మినిమం 2 పుట్ టీ ఈజ్ ఈక్వల్ టు ఇన్ఫినిటీ maximum 4 సో ఇట్ లైస్ బిట్వీన్ 2 to 4 రిమెంబర్ దిస్ ఈస్ ద గ్రాఫ్ డ్రాన్ ఫర్ వాట్ IL as a function of time, right? So successfully done. What is the potential drop across the inductor? Now the potential drop, current increasing or decreasing? Increasing. So L di by dt, dIL by dt. 4 into dIL, 0 plus 4 times e power minus 2t. 16 times e power minus 2t. (16 times e to the power of minus 2t). Done. Correct. Eighth question is the same. The potential variation of potential difference, all that you know already. VAC already they have given. What to find? You are asking VC versus time graph. The variation of potential difference A and C. A and C. Where are the points A and C? Oh, fine. What is VA minus VC? It is nothing but VA minus VO plus VO minus VC. VA minus C, VA minus VO is I1 into 2 plus VO minus C is opposite direction you are getting the current minus I2 into 3. They have clearly given what is I1 and what is I2. What is I1? 10 into e power minus 2t. This is 20 times e power minus 2t. And I2 already given 4 minus 12. This is how your graph is. Right. Don't get confused again. Let this be delta VAC. Put t is equal to 0. If you put t is equal to 0, you will get 8. Put t is equal to infinite, you will get minus 12. So the graph should run between 8 to 12. Yes, exactly. And it is e power minus 2t graph. So exponentially falling. So first option is correct. Next, the potential difference across AB. Potential difference across AB. I will write only the same. VA minus VO plus VO minus VB. Already we have this. I1 into 2. 20 times e power minus 2t plus VO minus VB. If it is VB minus VO, I would have written 3 into e power minus 2t. (17 into e power minus 2t). That's all. I got it. That's what they have asked here. Can see here. And again, CD. What is the drop across CD? Okay. My steps are still the same. VC minus VD is VC minus VO plus VO minus VD. VC minus VO we already have. VC minus VO is 382 plus 12. VO minus VD. VO minus VD is VL. Nothing but the drop across this 16. Already we have done this. 16 into e to the power of minus 2t. ఈ గ్రాఫ్ లానే ఉంటుంది ఇది కూడా. ఈ గ్రాఫ్ లానే ఉంటుంది. ఎలా? Put t is equal to 0. You will get minus 4. Put t is equal to infinite. You will get 12. Minus 4 to 12 graph కావాలి మీకు. That's all. Which one is matching here? Put t is equal to 0 here. 1 minute. Just let me check whether my observations are correct or not. VO అరే మైనస్ ఎందుకు రాశాను ఇక్కడ నేను? ప్లస్సే కదా. VO మైనస్ VD ప్లస్సేగా. ఇప్పుడు ఏమని చెప్పి t is equal to 0 పెట్టండి 28. T tends to infinite పెట్టండి 12. So it should run between 28 to 12. So this is the graph. That's all. I've done. Very good question. Now I'm still asking. Any doubts in this? Geetika, do you have any doubt? Ask me now.
No, no, sir.
Pakka.
Yes.
Aditya,
No doubt, sir.
Darshan, Bhargav. Next. Palvita, you have any doubt?
No, sir.
Sanjana, do you have any doubt?
No, sir.
Soumya, class కి రాలే ఇవాళ. Soumya, వచ్చావా రాలేదా? She didn't attend class. Right. Next, this is our question.